Subnetting is easier than you think. Now hold on, before you think I'm full of it, let me show you 4 simple steps I use to solve subnetting questions every single time. Whenever I have to subnet, I think about 4 things. What's the default subnet mask? What's the number of borrowed bits? What's the octet of interest, as I like to call it? And what's our increment? Now to make this more practical, I picked a random subnetting question from subnettingquestions.com, which by the way is a great resource to use for practicing subnetting. Here's the question. How many subnets and hosts per subnet can you get from the network 172.28.0.0/23? Okay, so step 1, find the default mask. 172.28.0.0 is a class B IP address, so its default mask is /16. On to step 2, finding the number of borrowed bits. The question uses a /23, so we've borrowed 7 bits beyond the default /16, so our number of borrowed bits is 7. Okay, so on to step 3, finding the octet of interest. The octet of interest is where subnetting takes place and is always where the borrowing ends. Since our borrowing ends in the 3rd octet, it is the octet of interest. This means subnetting starts in the 3rd octet, and we can start our binary calculations from the 3rd octet to save time. I'm going to overlay the subnet mask on top of the IP address. Looking at it this way, we can clearly see our network bits and our host bits. I put our network bits in red and our host bits in purple. Since we have 7 network bits, the number of subnets would be 2 to the power 7 or 128 subnets. You can see we have 9 host bits, so the number of hosts per subnet would be 2 to the power 9 minus 2. This gives us 510 hosts per subnet, as we need to subtract 1 for the broadcast address and another for the network ID. Okay, so we figured out the answer and we haven't even gone to step 4. Step 4 is there to help us find out each subsequent subnet using the network increment in the octet of interest. Let's look at a positional value chart to help us. If we start counting the number of bits we borrowed from /16 to /23, we're going to land on the 7th bit. Since the 7th bit has a positional value of 2, our network increment is going to be 2 in the octet of interest, which is our 3rd octet. For example, let's add 2 to our previous network of 172.28.0.0 in the 3rd octet. We then get 172.28.2.0, our 2nd subnet. 172.28.4.0 would be our 3rd subnet, and so on. Knowing the increments, we simply have to subtract 1 from the octet of interest in the next subnet to get the broadcast address of the previous subnet. If you enjoyed this content, please feel free to follow. I look forward to connecting with you and dropping more videos like these in the near future. Thank you.